Hey guys, Brian here. Welcome back to the shop. Today's video is a bit of a tips and tricks video and covers something that's not really covered very often that I see anybody ever talk about. Keith Fenner touches on it from time to time, but I don't really see anybody else mention it. It's about machines and wear and making up for wearing machines to do high class work. So, I'll tell you a story here. This month has been cylinder head month here at the shop. I've had a bunch of these to do. This is like the sixth head I've done probably in the last month or two. Another fire ring job, mill, and I like to get these as flat as possible. And since I've done so many of these here lately, I had gotten to notice that I was consistently getting a thousandths high in the middle on these heads. So I got to checking on it, and basically what's happening, I used a stare straight edge to set it up and indicate off of it, but what's happening is this mill table has got enough wear in it. With this 8-inch cutter on this 3-foot long head, in order to get off the head on each end, I've got to, use pretty much the full travels of the mill. Well, in the center, there's a thousandths wear in the table, and with the vertical head on here, basically the head is going down as it goes across and then comes back up when it gets to each end. So you're getting like a frown effect of what the head's moving, which is opposite of the cutter because the cutter's stationary. So you end up with a 1/1000th hump in this head, which is well within spec. I mean, spec is like 3/1000ths over the whole head of being flat. So, or under that, but as machinists, we always like to do the best possible and try and really get down there, especially on high performance stuff where it's at the ragged edge of being able to do what it's supposed to do anyway. So want to get this really good. So the tip and trick for today is, if you notice, instead of running this with the vertical head on here to where the table movement affects the cutter position, what I've done is I've put this up here so that the mill travel is perpendicular to the cutter face, and what that allows is this head can move up and down, and it can tip and flip and do whatever this way as the mill is traveling, but it's locked in the opposing axis, so the cutter depth maintains constant all the way across this head all the time, regardless of any wear that's in the mill, because it's perpendicular. Same thing if you had this turned the other way and you were using the vertical head, you can mill on the sides and it won't affect anything, but if you were milling on the top face, and then you would have a problem, the same problem as what I was getting with that thousandths bow, because as your part moves, it's getting away from the cutter and coming back to the cutter. So that's today's quick tip. Hope that makes sense. I'm not sure I explained that just the clearest as possible, but I'll throw an indicator here on this and show you that this is under 1 thou on this now across this 30 inches, and we're under 1/1000ths over 30 inches in all directions, and that's pretty good. It's not surface grinder, but it is, fairly high class mill work, which is what we're trying to do. So I get on with this job, but I just wanted to share that tip with you of how you can compensate for wear in your machine by thinking about your part setup versus the direction your cutter's moving. So Okay, so you can see by how little that indicator moved there that we're down definitely under 1,000. It's really not moved at all. It's sitting right there on 0 from one end to the other. So by setting this head up this way to where any wear that's in the axis that's moving won't translate into the cutter head, we're able to get you know, a right on, really good, precise cut performed to where it can maintain flatness across this long length. So even though there's a little wear in the machine, it can still do top-notch work. And that's so. Thanks for watching and thanks for subscribing.